No, I did.
It's really painful.
No problem.
So now I open it again. Okay.
Okay.
Okay, so the first talk today will be about Python in banking system from Maciek.
It doesn't work. Okay, good morning everybody. Thank you for coming to my presentation so early in the morning. My name is Maciek Dziergwa. I'm coming from Poland to you, and today I would like to share with you my experience about working with banks. Basically creating Python solutions for bank clients, but this is a very specific and quite complex client. I encourage everyone to connect me on the LinkedIn so we can stay in touch in future. If you have any questions, please ask it also during the presentation, so I can answer it at once, and nothing will be missed at the end. Small agenda of this presentation. I will take at start a few words about my company and a little bit about the background of STX Next. Then challenges of work with banks, so what are the specific things about this environment. I will try to show some general architecture of bank infrastructure, so we know at least a little bit about complexity of it. Then I will tell you what frameworks we use working with banks. Special slide for forms and tables, because this is a very, very important thing, and basically 90% of work for the transactional system for the banks are generating forms and tables. A few words about the build process, then a testing process. At the end, I will tell you a little bit about logging, special logs for the banks, and at the end, some observation what to focus when working with the bank clients. Do you have maybe any questions at start? Not yet, okay. So let's go on. STX Next. STX Next is a very special company because this is a Python software house. We are located in Poznań in Poland. Poland is the country where there were European Championships, so also in Poznań we have some games, so you should know a little bit at least about it. What is very special about us, we have almost 30 Python developers in-house in our office. We have basically only Python developers plus a few web developers and one tester. We don't have any sales people, marketing people, hardly any project managers. I will tell you a little bit later why. And if you add to this 3 remote developers plus nowadays we have over 8 internships, then will be very big team of Pythons enthusiasts in one place, and I think it's one of the biggest Python team in Europe, maybe in the world, that is working for other companies. You can see we have been started in 2005, so you can see how many days and how many hours we already worked for our clients. So it's over 140,000 hours we already did in Python. Yes, because it's mainly Python, so it's already something. You can see the team on the picture. It's not entire team, but most picture was done at the start of this year, so most of the people are there. What do we expertise in? Well, basically we expertise in Python development. We do 2 ways of work. We subcontract, outsource Python development work for other Python companies, mainly in Europe and United States. We also do in Python mainly web solutions, so we also are familiar in HTML, CSS, JavaScript, and all web technologies. So this is one stream of our work. The other is throughout our mother company, we create transactional systems for the banks in Poland, the biggest bank in Poland. So, and this is the topic I would like to share with you today. And we also evangelize Python and Plon in Poland. We are the biggest Python company in Poland. And one of 5 companies in Plon, of course the biggest one in Plon, because Plon is not very popular in Poland. We do everything we can to popularize it. So, first slide, challenges working with, when you work with banks. As you probably can imagine, banks are very complicated client. You can expect constant change and decision gap. Well, banks are very big companies, so taking decisions on their side is very complicated things. Usually it is like this, that we talk with a lower level of people. When we agreed to something, then it has to be accepted throughout management. So usually it takes a lot of time, a lot of weeks, and suddenly there is a decision, but the deadline is already very, very short, so we have to work very fast to make the deadline, just because of this decision time taking on their side. So you have to be prepared for it. Security, lack of access of production instances. Banks host their systems by themselves, and we never have access to the production instance in any way. We only can ask for logs, and not, I will tell it later about different forms of logs. And of course security, so everything usually takes much more time, just a common task than usual, because of lack of this production, access to the production instance. Many parallel production environments. Because of security and availability reasons, banks usually have 2-3 locations of the same infrastructures in different places in given countries, so you have to be aware of it, and remember, when you do a deployment, usually you have to deploy on all these environments. Offline distributions. When you deliver some solution to the bank, it has to work offline, and they just tested, they unplug the server from the internet. When if it's in the instruction, they run a build out, and build out has to run in an offline mode, so it will not download anything from the network, because there is no network. It really cost us a lot of time to prepare such a distribution. Frequent delivery, because of different campaigns, marketing campaigns, and this decision gap, you have to deliver software quite often, sometimes a few times a week. Logs cannot contain sensitive data, so no way to keep passwords or some user information in the logs. When there is a problem on the production instance, you ask banks for a log, logs, but this you have to prepare earlier the logs in the form that they don't contain this passwords, the username, logins, so you cannot use it later just to fraud or do something with data. So allowed only use of standard frameworks, applications. On this conference, we can hear about new things, new frameworks that's showing up on the market. With the banks, it's opposite. You are not allowed to use the newest software. With, for example, Apache, you use at least one number before the actual one. For example, we wanted to use for a bank engines and varnish for the caching. They said, of course, no way. And the reason why they did it was surprising for me. They explained it that the biggest cost of application in the banks is maintenance and keep with it and support. they have to support it 24 hours a day, 7 days a week. So they have a team of administrators that are qualified and trained with all the things, all the frameworks. So they are not going to use any new framework because cost of maintenance of training all the administrator and changing procedure to host varnish or engines is so big that they just want to keep with the simplest and most common application. So yeah, you have to remember it and forget about object databases and so on. You just use they use Oracle, so everything has to work on Oracle or maybe PostgreSQL. After 2 years, they agreed to Postgres, but that was all. So we were not, for example, was able to use ZODB with Plon. We have to use some relational database. Any questions? Yes, please.
To put Python in such an environment?
Well, we work through mother company, so our team is already quite big, but still not big enough for the banks. Yes, so our mother company is almost 100 people. So in the past, the system was created with Perl, and something about 5 years ago, they decided to migrate to Python. So this we work for the biggest bank in Poland. I cannot say the name, but you can find it easily on the web. Yeah, there is only one, the biggest one. Anyway, they were opposite against Java and Microsoft in some way, so the natural choice was for Python. But it's not that nice because I know in Western Europe, they prefer C++ instead of Python, for example.
A combination of Java and IIS. So it's all WebSphere and IIS.
Yeah, I was talking also, we also work with Netherlands, and I was discussing, and they said, well, no Python, no Python. Only maybe on the web level, but not in the core. And you will see in the moment that, well, Python is only a small part of entire infrastructure in the bank. Yes, please.
For companies that work for the bank, and they all tell me that one of the biggest problems is the quality of the infrastructure, in the sense that they are so conservative that they never update stuff, and there is stuff that has been built so many years ago that nobody knows how it works anymore. Just don't touch it. Is it the same everywhere, or it's just that bank?
It is. It is similar, not the same. Yes, because for example, recently in this bank they migrated to the new servers. This process took them 1.5 years to migrate from the really old servers to the new one. So when we created some applications, it has to be efficient on the servers from 3 years ago. And changing the infrastructure was really a horrible step. And for example, we already worked for them 3 years, so Apache version didn't change throughout this time. So they are still using the same Apache version. It is like this. It's because of procedure. They have to have a procedure for everything in the bank because they have a lot of audits. That's why any change is very expensive. That's why they don't do it.
Your primary customer, or are you working with other banks?
In Poland, in this moment, we work for 3 banks. The biggest one is really Polish banks. The rest are European banks, so from Germany, from the other one, I think it's the Italian bank. So these banks own our banks. It's Polish brand, but the owner is for sure one from Italy. And I know that it was it was written in Java, then I think they have written it into C or something like this, the guys told me. Okay, I have to go on because time is running. really general look on the infrastructure of the banks to show you how complex it can be. Very typical for a bank is the name at the top of it. It's channels. Banks communicate, business in the banks communicate through channels. Channels, so www is only one of the channels, the web channel. There is mobile channel, there is IVR, there is call center. So many different channels client can connect to the bank. We focus here on the www channel, so web channel basically, and also mobile channel because we do also mobile applications. We have Apache in front as a proxy. There is really a lot of these Apaches, so dozens, not even 10 or more, but I'm not even aware how many of them is there. There is of course load balancer because we are not very deep into infrastructure, so we even don't have entire picture. And there is much more layers of Apache, so it's not only one Apache, at least 2, 3, or 4 cascade doing different things, different tasks. And remember that this entire infrastructure is multiplied 2, 3 times in different localizations. Then as a web layer we have pylons as a web framework. And this is our Python work where we do our work. So web layer pylons based, and on left hand we have CMS, this is Plon CMS, but only to input data. Then the data are using our static deployment module transformed to static HTML, and this static HTML is synchronized with all Apaches, basically all this either Apache or pylons, because on the pylons where we're using Diazo, we integrate static content with dynamic content. What is very interesting thing is this communication bus, and that's almost all about Python. Communication bus is implemented in C++, and all communication goes through this channel. Using different transport protocols. One of the common in banking, very old one, is Tuxedo. Usually cash machines communicate with this transport, but they created, our mother company also created very proprietary transport, and it's implemented in C++. The nice thing is that you just send, if you want to send XML message to any of these components, you just send it to the communication bus, and you don't care where it goes, to which component it will go. Usually there is components are multiplied, and communication bus will take care of it, that if one of the components is down, it will be sent to the other one. It's doing all the load balancing, and it's very, very fast. Different models you can see here. One of the main one is Workflow Manager here. It's implemented in C++, also works as a dispatcher for the messages, but extensions can be written in Python. So very often we do some small things in Python on this level. And a lot of other components. Here you can see the core accounting system for the bank. So we are not doing the core accounting system. These are very, very big products doing for the biggest companies in given country, consulting companies basically, but we just interface with it, with a gate, and we create everything around it. You will be surprised how many applications in the bank communicate with through the files on FTP or any other protocol. It's very surprising, but really a lot of stuff between banks is synchronized through the files. And here you can earn a lot of money doing business, just implementing integration between banks. Of course, there are gates for to mobile operators, SMS, emails. There is a gate to Visa and MasterCard. There is some special administration console, so administrator can see all the components in the environment, like how they work. They can restart it, check the logs, and so on. There is a session server, also implemented in C++. These all modules, components have been implemented by our mother company, C++, because it has to be very fast. Session server is also stores also some small session data. and it has to be stateless, so many session servers can run in the same time. So this is just general overview of architecture of banks that shows you how much work, how much time it takes to create even simple solutions, because usually to implement some functionality it has to be implemented on many levels, a little bit in CMS, a little bit on the web layer, and a little bit in a given component, or at least this component has to be configured to the given client, given system. Any questions here? Because I was trying to make it quite simple. It's maybe it's not, but in fact it's even much more complicated than it shows here. Okay, so let's go on. Python frameworks we use for the banks. As I already told you, Pylons is our main web framework used for generating entire web or mobile content. CMS, as I told you, just for inputting static data. So for the main website, information website, marketing is working, marketing department is working with CMS. It is accessible only through the bank intranet, so you cannot access it from outside. And it has a scheduler and static deployment model. One interesting thing that you will have to have in bank. Usually, marketing department, well, something changed, some information, for example, currency exchange or some other interest rates change and has to be published during on the midnight. So what we have, and additionally, static content has to go through the quality assurance of the content. What does it mean? Marketing changed the website, changed the content, then they generate static version of the entire website during the day. Yes, they check check it on the quality assurance phase if it's okay, if nothing is broken, and then they schedule that this content should be synchronized with production with static Apaches during the midnight. Usually CMS doesn't have this functionality, so you can do it if Plon, but only if Plon is available directly from the internet. So we had to implement all these extra models functionalities. This one is open source, so you can of course reuse it with them. Also, because of this entire infrastructure, all the URLs has to be relative. Plon doesn't have this functionality, so we had to patch ZOP really deep inside to make all URLs that are published to be relative. We used a little bit of Django for some block applications. Diazo is not Python, but we also use Diazo for integrating content on the Pylons level. And that's all as for frameworks. Everything else is pure Python. The most important things about transactional systems for the banks on the web layer are forms and tables. 90% of views of the transactional systems are forms and tables, and but the forms are not very simple. They are usually very complicated. So the multi-pages form, usually the process looks when you do some money transfer or something, you have one or more forms, then you have confirmation page. And here, after confirmation page is submitted, then there is an XML message to a backend system, and then you have a thank you page. So to accomplish it, we created a special forms library that supports this process, and extra things about these forms. What is interesting? Complex field dependencies. So, for example, you have a form with 200 fields, but these fields are dependent on each other. And dependency is done with JavaScript, but you have to remember about validation. So if field is, if given field is hidden, then validation, you don't validate this field. You have also dependencies of field sets. So all of it makes it really very complicated to implement it, and if you have to do it manually all that each time, it would cost you a lot of time to implement and a lot of problems. We create special library that is very useful for this. So creation of forms is much more simpler. Another things, specialized forms, fields, and widgets, for example, credit cards, number, bank account, and many others. They are very common between banks and between different forms, but not very popular in other systems. So these forms are also this fields and widgets has been also implemented and now reused for other screens. Tables filled with data from a backend system. So usually this data for the tables comes from XML. We also have a library that generates these forms. Any questions? Okay, yes, please.
A lot of these forms, are they the banks, like do the bank's customers use them or the bank's employees? Like are they customer facing or for internal?
For customer. So this, for the bank's customer. So yeah, when you log in and you want to make a money transfer, you can see a lot of forms, login form and then transfers. And if you want to buy some stock exchange or do start do anything basically, order new credit card, do see your credit card history, account history, and so on. So everything's basically forms and tables. That's all in the banks. Of course, you have table, usually some interest rates or something, some static pages, but it's really few percent of entire web solutions. Okay, the build process. I already mentioned when you create the system, you have to deliver it to the bank. Builds, so distributions have to be in offline mode. So if you deliver some solution to the bank, Apache, all the libraries, you assume that there is only a clean Unix system, some Linux, and then all the libraries has to be with in your distribution. You delivered it to the client, to the bank, and they started in the offline mode. We have two kinds of distributions to the bank: patches, so we just deliver a single Python package that has been changed, or full distributions, so all the package, all the applications. Usually such distribution can be something like 100 megabytes or more. So it takes really a lot of time to prepare this distribution. Each distribution has to contain release notes and step-by-step installation and migration manual. What administrators do on the bank side, when they get the distribution and they have to deploy it to the servers, they just take installation manual and do a step-by-step actions. If something goes wrong, they give it back, so even if there is some character misspelling or they know what was wrong, some vhost was missing or something, they don't care, it comes back to you. You have to fix it, check what is the problem and give them a proper working solution. Usually they are much better in administration than we are, but still they are not allowed to do anything by their own. So if something doesn't work, they just give you the error message and it goes back to you. Also, they have some special way of putting it online, so they can revert to previous changes very easily by just symlinking different distributions on the server. So very nice thing. And because it works on the Apache level, so you are not there is no any stop of the application. It's only just restart of Apache that is very fast, very nice and simple solution. Questions? Yes, please.
What format are you delivering these in? Is it just a tarball or RPM, steps?
Sorry, can you?
What format are you providing?
Format. Our mother company has prepared some special scripts for making this distribution. We deliver it as a zip file, so everything is in one file, and basically it's going through just Bugzilla. We use Bugzilla with bank, and as distribution goes as an attachment. It's all because history reason. Everything has to be in the history. As an installation step, it's just a text file, yes, so simple text file. Release notes are also in the text file, and the steps that for the migration are also in the Bugzilla comments. So then each distribution has its own bug, and you can see the entire progress, how it goes on the different servers, because in the banks it also has to each distribution has to go through many steps before it's put on the online. I will show it on the next slide, on the testing slide. Okay, we have 5 minutes, we have to go on. Testing, developer testing, so just common testing, we know it. Then we have a human tester on our side, so we have a local QA instance, and our tester is testing all the changes. Then we do a distribution, it goes to the quality assurance instance on the client infrastructure. They have their own testers, they test it. If it's okay, it goes to the production instance in the client infrastructure. Quite simple, but very time-consuming thing. Logging. We have different kind of logs. Business, this is the special format of the log for the banks, so banks know how transaction goes from business point of view, not our technical, so we can see all that things. The rest is for us, but the business, you have to be aware that bank will ask for a business logs in the given format, and you have to prepare logging infrastructure to make this business logs. And the last one was to focus so some kind of lesson learned from the banking systems, confidentiality. So do not put anything online. For example, we usually communicate with client by screenshot. Something is wrong, we use Jing or some other application, and we just upload it or through our FTP that was accessible through the web, but it was not protected with password. And suddenly banks, they usually scan, banks administrators scan the internet looking for different things. If they find that something, some screenshot of their application is publicly online, they already call it a security incident, they report it to us, and of course we have a lot of problems. Then we have to close it very, very fast. For example, we made a screenshot of some internal application on our website to show it as a reference. They also ask us to remove it. Nothing has to be, can be publicly available. We are connected with them through VPN tunnel, and that's all. So we have to be careful about it. Estimation should assume build process. It costs us, so usually bank asks you for make a small change that takes half an hour, usually estimated at least 1 day, because 1 day is necessary to do all the test and distribution process. We have to learn it because we are not used to it for small changes. Bank are corporations, so do have paper for everything. You don't need signature, but just confirmation in email, or basically we use Bugzilla, so it has to be in Bugzilla. And look out for internal politics, because really it is really a problem. Usually banks employ a few thousand of people. IT department has something like 40-50 people, and they don't like each other. IT doesn't like marketing. We have to work both with IT and marketing, and they really hate even each other. So you have to be really very careful about working with them. Okay, and that was my last slide. We are on time, so of course you can contact me, and please ask now questions. We have at least 5 minutes for discussion. If you need some secret information about things, I can say a little bit what I can. Yes, please. No more time? Okay.
Okay, thanks. If you were able to build a new bank system from scratch, how much work do you think to need to be used to build the core features as compared to this existing system? Thank you.
you have to remember to create bank from scratch. You have to have two things. One is the core accounting system, and there are out-of-the-box solutions for that you have to buy for really big amount of money. I'm not even aware of it because it's much more than I can imagine, and licensing costs much more than imagine. We don't do it. Then for this core system, you need to make these channels. And we are doing these channels, and the cost of these channels usually is at least 10 times cheaper than done by the same company that is doing the core system. It's because they usually do it with Java or something and licensing it because they are so big. We are much more agile, much more cheaper, but it's hard to tell how much it will take. About money, I'm not able to say, but with hours, the project usually takes thousands of hours. So forget about 200, 300 hours. So small change request usually takes 100 of hours. But if you want to do entire functionality, like for example, we created a version for the children, yes. So it took a few thousand of hours. These are so, and if you want to create entire new bank, so I've 20,000 of hours is something like this. So just take the average rate for the programmer, and you will know the amount. Yes. So 1,000 of hours is nothing. It's all because this procedure, these things, the entire infrastructure. So many different components has to be created to create such a implementation, and you have to really integrate with a lot of different companies because of security reasons. Usually banks doesn't use only one provider. They have different companies doing small things. So we do channels, other company does some product for credit cards, another company is doing something for stock exchange, and so on. And because it's so big market, so many companies want a little bit of this cake, there is really a lot of companies around. Yes, please.
Have you tried convincing the bureaucrats that the old versions of the software has known bugs and probably available exploits? And the second question, plain FTP, available to the internet, not SFTP?
The first question I didn't understood. I will answer first the second question. All these FTP connections go through the VPN connections directly in the backend, and it doesn't go through the internet just like this.
Okay, so just the intranet.
Just the intranet, yes.
The first question was, have you ever tried to convince the bureaucrats that all the versions of the software that they insist on having might have known bugs and available exploits?
No, we are too small, and they are because they are responsible for maintaining it and support it. It's very own decision, so it's very internal politics. Of course, they are sometimes they do upgrade and so on, but we don't take part in it at all. So it's not our decision. We only can tell them which CMS version of Plon to use and so on. But it's because it's not very critical. It's in the offline mode almost. Yes. So for here, it's their job, their responsibility. Two minutes left. So we have.
I heard about some figures for the development of the web application, not the web application, the mobile application of a bank, and that's a very big project. Like they spent 10 million euros. How do they justify? Because the complexity is really big, I know, but the amount of money, I think, is, from my point of view, not proportional to the complexity of the project. But I guess, of course, banks don't throw away money like this. How can you explain this kind of phenomenon?
It's because the bank is the public company, so I know how much they earn money per year. It's really a lot, much more than you can imagine. I would say one thing, a lot of different things is politics, yes, and it works everywhere, even for marketing budgets are completely even crazy, and agencies that create the visual design takes much more money than we do implementing everything, entire stuff, so even it's much more cheaper for us. For example, we also create mobile version, and creating mobile channel, mobile application, of course, simpler than the web, doesn't cost 10 million of euro zlotys anyway, because it can be done within few hundred of hours, or maybe 1,000-2,000 of hours. So it doesn't give a few millions of it. So if bank paid 2 millions or something, there has to be other reason for it. It's a business reason, and we never know why it's like this. And it's normal, because it works for all the banks, I think, all over the Europe. The amount of money is so big, the budget is so big, that you never know the biggest cakes who wins, yes, who do it. For the smaller things, they have to have many companies, as I told you, just to pretend that they are not, monopolists or something. But the most lucrative contracts usually are not reasonable in some ways.
Okay, so unfortunately the time is finished. The next talk will be about turbo gears, if I remember correctly. And one thing, just before leaving, I remind you that if you want to download the talks about EuroPython, you can find them in files.ep, which is a subnet of this network. Oh, so
if you have more questions, you can find me somewhere and contact me on LinkedIn, on mobile, and I have some extra cards, so I can give you my cards. Thank you very much.